Hello, everybody. Welcome back to AP Chemistry. We're in Unit 4, taking a look at Section 3, reaction types of oxidation and reduction reactions. This is a new one for people in Gen Chem. We don't typically talk about redox reactions. That's a short way of describing these. And so let's take a look at what that actually means first. And let's put it in terms of a simple equation like iron plus sulfur makes the compound of iron 2 sulfide. Okay, so there are some things to determine when we're trying to figure out what's going on within a redox reaction. We're going to be taking a look at what is going to be transferring in terms of electrons, and so that regards the oxidation states. Okay, what kind of charge it will take on. So if you look through the rules here, we have an oxidation state of something that's just by itself. For example, my iron or my sulfur, that would have an overall charge of 0. Okay, so they are neutral, and so there's a 0 charge on both of these. But when we get together and form a compound between the two, there's got to be some things going on. So we see group 1 metals have an oxidation state of +1, group 2 has an oxidation state of +2. We have oxidation state of fluorine, and in fact, pretty much everything in that entire column has a -1. We see a hydrogen has an oxidation state almost always of +1, and oxygen almost always has an oxidation state of -2. Okay, so any of these things, we're going to be seeing a group -1, -2, -3, and so on. So how does that translate to this? Now, sulfur is in this group 16 element. So that means that my sulfur will take on a -2 charge. And remember what that means is it's going to be taking in 2 electrons. To do that, then, iron must be willing to give up 2 electrons to become an overall neutral charge for the compound. Now you'll see the phrase oil rig here. What I mean by that is in terms of the electrons themselves, there's a couple things that were going to be going on with the actual compound. We call those redox. All right, so going back to my oil rig concept, I saw that my iron was a +2 and my sulfur was a -2. They were originally 0. So what happened here? Well, if I use it in context of the oil rig, like I said, I'm using that phrase because oxidation means loses electrons. So in this scenario, who's losing electrons? To lose something negative means that you're going to become positive. My iron went from an iron that's a 0 charge to an iron that's a +2 charge. It must have lost 2 electrons. Now, who gets reduced? Okay, that refers to the reduction part. To reduce means it's going to gain electrons. And you're going to have to keep telling yourself that along the way. Oxidation means to lose, reduction means to gain. Well, to gain electrons means I'm going to become negative. My sulfur started as a 0 charge, and it became a -2 charge when I formed the compound. So the agents that are redoxed here, my iron was oxidized and my sulfur was reduced. And that's all you need to do for these beginning stages is just get comfortable with what's occurring within the compound. Okay, so let's practice that a little bit in terms of just assigning oxidation states, and then we'll take a look at it in action within the compound. Okay, so remember the rules state that you have a -2 charge on your oxygen. So overall, this thing has to be neutral. So a 2 times a -2 is -4. My carbon must have been a +4. Overall, I see my -2 on my oxygen. This is 6, but you'll notice that nitrate has an overall negative charge, so it means I have 1 leftover electron. So if this is -6, my nitrogen must have been a +5. Here I have silver, which is always a +1. Here I have a -6, +1 is a -5. And so to make it overall neutral, I have a -5 on, or sorry, a +5 on my nitrogen. Okay, now let's look at the actual equation to see what's going on to balance it all out then. So my oxygen, I'm just going to go through and quickly do that. I have my sodium as a +1 because it's in a column 1. My chlorine is on the column 17, so those are all going to be a -1. And here's my +1. And my silver I said was a +1. So you'll notice that the only thing I have left over is going to be my nitrogens. Okay, so here's my oxygen. That's a -6. +1 is a -5, so there must have been a +5 here. Here's a -6. +1 is a -5, so my nitrogen must have been a +5 here. Now notice that my silver started at +1, ended at +1. My nitrogen, +5, +5. My oxygen, -2, -2. +1, +1, chlorine -1, -1. This is not redox. This, in fact, is your cue that this is one of those from the previous one, taking a look, and this is going to be a precipitate reaction then. My silver chloride is going to be precipitating out, and so, like I said, it's not a redox reaction. Okay, just identifying that is part of it, and you're going to be asked, is this a redox reaction or something like that? That's how you do it. Just take a look for what's changing. All right, so let's take a look at the next thing. We're going to be looking at, in traditional chemistry, we call this a combustion or complete combustion. But let's take a look at what's happening. Remember, an element by itself starts out as 0, but it became a -2 on this side. My hydrogen is always going to be a +1. And notice 1 times 2 is a +2 and a -2. That's balanced. I have +4, so this must have been a -4. So I have a -4 on this side. This must have been a +4. So is this a redox reaction? Well, remember, we have oil rig. Okay, so it's losing electrons. It's becoming positive. That's exactly what's happening with my carbon. The carbon went from a -4, that's the carbon within methane, and it became a +4. Okay, and that's when it became was a part of carbon dioxide. So if something is going to be oxidized, that means that something is going to be reduced. Remember, that's going to be gaining electrons. So who's gaining electrons? Well, if you take a look, my oxygen started at a -2, and it became, or it started at a 0, and it became a -2. That was the case in the carbon dioxide as well as when it was in the water. So it got reduced in a couple of cases. Okay, redox, definitely. Now, take a look at one last example of those, and then we'll go into how to balance these things. All right, one last example we're seeing with lead 2 sulfide. Okay, here's my oxygen. That becomes a -2, -2. So on this side, sulfur is in column 16, so that's a -2 column. That must have been a +2 then to balance it out. Over on this side, I see a -2. That's a +2. And you'll see on this side, I have 2 times a -2 is -4. That means my sulfur is a +4. Did my lead change? No, that's not oxidized, nor is it reduced. So again, with oil rig, I see that oxidation means to lose electrons. It becomes more positive. Who became positive? My sulfur became positive. Okay, so my for oxidation, sorry about that. My oxidation was my sulfur went from a -2 into a +4. My reduction then, once again, is my oxygen, when it was a gas, went from a 0 to a -2 because it's gaining those electrons. Okay, now we know the skill of just assigning those oxidation states, and we definitely know that what agent was oxidized and what was reduced. Now, the big thing with this chapter is how to balance and write and balance equations. Let's balance the redox reactions as we go. Now, here are the general steps, and it seems like a lot, but it's actually quite simple if you just break it down by individual skills. And let's do it in terms of the copper ion plus the iron element by itself will become the iron ion and copper element. Okay, we're going to turn my iron into copper, if you will. First step, we're going to separate things into half reactions according to redox. And so we saw two things happening here. And just to break it down a little bit, notice that I go from a positive to a neutral. Okay, so that means that I gained electrons. And again, oil rig, who gained electrons? Okay, well, my copper gained electrons. That means that this guy was reduced and my iron has lost electrons because it's become positive. This is oxidized. Okay, just being able to identify those. That's the first step. Okay, it becomes positive by losing those electrons. It becomes more negative by gaining electrons. Okay, that's the first step. Now, to do this now, notice that I have a +1 on this side and a +3 on this side. So step 2 means I'm going to have to balance the charges on both sides by adding electrons to the other side. So to do that, to make sure that my pluses on this side becomes the neutral. Notice that I gain an electron on this side. And on my iron then, I'm going to gain 3 electrons on the product side to remain neutral overall. Now here's the key I want you guys to focus on. Keep your arrows together. Okay, this becomes really messy. One thing to save yourself some headache in the long term is to keep your arrows above one another so you see everything on the reactant side and everything on the product side. Okay, now next step is to balance the electrons by multiplying the entire equation by a multiplier. Now what I mean by that is this. The simple way is to see, okay, I've got 3 electrons on this side, and I only have 1 up here on the reactant side. So I could multiply the entire thing like this by putting a 3 on the outside. But what that means is you're going to have to distribute the 3 to the copper, to the electron, and to the copper on this side, okay? So to keep it simpler, you might want to do something instead and just go ahead and distribute that as it is. So notice I did the 3 to each of those things like I just mentioned. I'm keeping my arrows all above one another, so I see that I have 3 electrons on this side. I have 3 electrons on this side now. I did step 3 by balancing the electrons. Now let's add up the entire set of equations. Again, I have everything on this side, and do yourself a favor, just write everything sequentially. So the first on the reactant side, let's deal with the top of that, and there's my copper with my 3 electrons. Now I also have in here my iron, don't I? Okay, so that takes care of my reactant side. Now let's take a look at my product side. Again, going up to my copper, there it is, and my irons and 3 electrons. Okay, pretty simple. Now, the next step is to cancel all the electrons. Because I have 3 electrons on this side and 3 electrons on this side, I can cancel those out. They factor everything out there. And there is my balanced equation in a redox format. Okay? Now, this looks like it's a little bit simple. And it's like, why all this work for something? But you're going to see in other examples, we're going to have leftover electrons. We're going to see a bunch of other things going on. So follow those steps. Pretty simple. Now, notice with this, I have just these elements going in. There are a couple extra steps if it's something like an acidic solution. By acidic, it means I have like hydrochloric acid, nitric acid, or so on. I have this compound with a hydrogen in there. So we start out those types of reactions, just to talk you through the steps, the exact same way. Identify your redox. Then balance your elements other than hydrogen and oxygen. Balance everything. Now we get to go through and balance out your oxygens by adding water to the other side. You'll see me do this in a moment. And then we can balance the hydrogens by adding the hydrogen ion to the other side. And then do your charges and then balance the electrons and do the exact same thing we did with the previous example. Cancel out your electrons then. Okay, that will give you your redox. We do the exact same thing with a basic solution, which means that it's going to have a hydroxide present. Okay, separating the half reactions, do a redox. Again, balance everything other than hydrogens and oxygens. Balance your oxygens by adding water. Balance your hydrogens by doing a hydrogen ion. And then balance your charges. And then balance your electrons. But this time we're going to, after balancing, adding the equation, cancel out your electrons. And this time we're going to add hydroxides to eliminate the hydrogen ions that might be left over. Okay, that's just the mechanics of it. Now let's put it into action. All right, so got a couple of examples here. Let me do them step by step with regards to a redox reaction. Now, first thing that I see here is hydrochloric acid. It's a compound that starts with hydrogen. So this is a little bit more complex. I'm going to have to follow 8 full steps. Let's take a look at them in turn. Step 1, okay, now I'm going to just write oil rig so we can get that part again. And so step 1 is to figure out all of those oxidation states. -1, +1. -2, -2. Let's see, we've got those taken care of. This is going to be a +1. That's a -1, making this a +1. This is -1, making this a +2. Element by itself is 0. Let's see, what else? I see, okay, here's a +1. So I have -8 plus 1. That must have made my manganese a +7. And I think that covers all of our elements. Okay, so the question is, who's oxidized and who's reduced? Okay, so step 1. Identify the redox. Okay, so let's just do the oxidation and reduction here. And gaining electrons. Who gained electrons? Okay, so I see hydrogen was a +1, that never changed. My chlorine, a -1, that never changed. However, notice that this chlorine and this chlorine, that one's changed a little bit, but what happened is it lost that particular electron right here. Okay, so my chlorine went from a -1, that's from my hydrochloric. This one stayed the same, but this is where it changed. And so it became a 0 charge. Okay, that's oxidized. Who's reduced? Well, my manganese, you'll notice, went from a +7 to a +2. Okay, so he gained electrons in there. And so that's the rig part. Reduction is gained. And so my manganese, out of this whole thing, it was the manganese or manganate polyatomic ion, which has a -1. This is a -2. So this is 6. This was a +5. And it went to a manganese that's a +2. Okay, notice that I can't split off this oxygen because potassium permanganate looks like this. All right. So that's step 1. Now let's take a look at step 2. We're going to balance all of our elements except for my oxygens and hydrogens that might be present. So notice I'm just going to keep rewriting what I've got. I have my permanganate here, and it became the manganese ion. And notice that I've got 2 chlorines here. So one manganese, one manganese. I've got 2 chlorines here, but only one on this side. And so I'm going to need 2 chlorines. That's the ion. And keep my arrows all lined up nice and neat. I have a chlorine with a 0 charge. Okay, let's take a look at step 3. Step 3 says we got to balance our hydrogens and oxygens. There's my oxygen. I've got to balance my oxygens by adding water. Notice I've got 4 oxygens here. So I keep rewriting what I've got. I have my manganese here. I have my 2 chlorines. I'm just going to keep rewriting everything that I've got. I just add a layer. Now notice I don't have to do anything with my chlorine, do I? I don't have any oxygens. Here I've got 4 oxygens that I've got to take care of. So how do I balance out my oxygens? I add 4 waters. There. Now I have 4 of my oxygens taken care of. All right, let's take a look and balance with that my hydrogens. Okay, how do I balance out my hydrogens? Well, what I do is I add hydrogen ion to the other side. I balanced out my oxygens first. Now I've got 8 total hydrogens. That means that I've got to have 8 hydrogen ions on this side. There. Now my step 3 and 4 are taken care of. Now let's take a look at step 5. Okay, step 5 says that I need to balance my charges. Okay, so once again, I'm going to keep everything nice and neat. I have 8 hydrogens. I have manganese and oxygen, -1. And on this side, I have my manganese ion. And I have 4 waters currently. Okay, I have down below, I have my 2 chlorine ions. And I have just the chlorine gas. Okay, so I'm just rewriting everything. Now let's take a look at charges. On this side of the equation, I have a +8 and a -1. Okay, on this side of the equation, I have a +2. Okay, so +8 and a -1, that's going to be a +7. And on this side, I see that I have a +2. So I need to get them balanced, and so that means I'm going to have to add 5 electrons to this side. On this part, I see that I have a -2 on here and a 0. Well, how do I balance out electrons? I get 2 electrons on this side. Okay, so now I've balanced out my charges. Now let's take a look and let's actually balance electrons between the 2 equations. Here I see 2 electrons. Here I see 5 electrons. So let's look at step 6. I'm going to be balancing my electrons now. So how to do that? Well, if I've got 5 up here and 2 down here, my common multiple is 10. Okay, so that means that I'm going to have to get 2 outside of everything. Okay? Hydrogens, manganese, or the permanganate. I keep saying manganese. Okay, and remember, I'm going to keep going here. And remember, this too is also going to distribute to the manganese ion and my 4 waters. Now, to get them balanced on this side, now I have 10 total electrons. Let's get 10 on this side. That means that I'm going to have 5 times my 2 chlorine ions. Notice my arrows are lined up here, and I'm going to get chlorine plus my 2 electrons here. Okay? It's just easier if I see that I've got the 5 distributing. All right, so let's add up all the equation. Okay, so this is step 7. Okay, now I see that I have, on this side, I have 10 electrons. I have 16 hydrogen ions. I have 2 permanganates. I have 10 chloride ions. Okay, on this side, I have 2 manganese ions. I have 8 waters. I have 5 times my my chlorine there, so that's 5 Cl2s, and I have 10 electrons. Okay, so I've added that all up. Now, step 8, let's cancel electrons. How many electrons? I have 10 on this side. I have 10 on this side. So I can cancel out my electrons. What am I left with? Okay, so here's the big reveal with everything. If I do a nice job of doing this step, nice and neat, then I can just simply translate it all down. Step 8, I have 16 hydrogen ions. I have 2 of my permanganates. I have 10 of my chlorides. I have 2 of my manganese ions. I have 8 waters. And I have 5 chlorine gases. Problem is done. There's a lot of steps here, guys, but it's not hard. Don't make it hard. Don't convince yourself it is hard. It's not. It's just going through the steps. It's time consuming. That's what it is. Okay, we're not going to do a ton of these. So, do a nice job of just going through and following the steps. Let's do another one taking a look at zinc and nitric acid. This is an acid here, so I'm going to incorporate all 7 steps. If there's no acid, the problem becomes a little bit simpler. So let's do our oxidation states. 0 because it's by itself. -2, -2, -2, -2, +1. Let's see, this is going to be a +2, +1. All right, so -6 +1, this is a +5. I see a -6. Right, okay, so this becomes a little bit trickier. I've got a 6 times 2 is 12. There's my +2 is -10. Okay, and so we're going to be multiplying that. This must have been a +5 then. Okay, that gets a little bit tricky on that one. I see this is a -2, so this must have been a +2. And that should take care of all of my elements. Okay, so who's my redox? Okay, so step 1, identify your redox. Again, going back to oil rig. Okay, so who gets oxidized? And who gets reduced? Okay, I see that my zinc is going from a 0 to a +2. That means that he loses electrons. Okay, so the oxidation part is going to be my zinc. That's going from a 0, and it's going into a +2. All right, so who gets reduced? Who's going to be gaining? So it looks like my oxygen, let's see, is going there. It's all -2s. I see that my hydrogens are +1s. And so who ends up getting there? Well, this entire part becomes, let's see, the nitrate itself is going from the NO3 as a -1 overall, and over on this side, it's going to become the NO2 with this, because I see a -2, and the nitrogen is a +5, but over here, my nitrogen is a +2. Okay, so it's a -5 on this side, a +2 on here. This nitrogen stays the same. All right, so step 2, let's balance. That was step 1. Step 2, let's balance all the elements except for hydrogens and oxygens. Okay, so I see that my zinc and zinc, I've got one there. This nitrogen and nitrogen, that's balanced. Step 2 is done. Let's take a look at now step 3. Let's balance the oxygen. I've got one oxygen on this side, and so, like I said, step 2 is completed. So let's go into step 3. I see that I've got, now just rewrite everything nice and neat. I see that my zinc was a solid, and it's going into my zinc. That's an ion. Let's take a look at the reduction part. I see that I had nitrate. That was a -5 on this side. That becomes a +2 on this side. And so I have one oxygen to account for here. And so to do that, I needed to have, let's see, sorry, I've got 3 oxygens here. I've got only 1 oxygen here. So I need to gain 2 waters. 2 more oxygens, +1 is 3. Here's 3 oxygens. Okay, so that's step 2 taken care of. Now let's take a look at step 4. Step 4 says, let's take care now of my hydrogens. Now that I've got these all taken care of, I've got 4 hydrogens to account for. So I'm going to add 4 hydrogens to my equation. Now notice that I started with zinc. We haven't touched him yet. Haven't needed to because it's there. But I have 4 hydrogen ions plus my nitrate ion. That's going to give me my nitrogen. That's a +2 and a -2. And my 2 waters. Okay. So that's step 4 taken care of. Let's take a look now at step 5. Step 5 is going to be adding electrons to balance the charges. Notice on this side, I have a 0. On this side, I have a +2. So let's take care of that. Let's actually get my zinc. That's a 0. He's going to become a zinc with a +2 by adding 2 electrons. Okay, on this side, I see a +4 and a -1. So I have a +3. And on this side, I see an overall charge of 0. Okay, so to do that, again, I have my 4 hydrogens and my nitrate. And I see my nitrogen here, -2 +2. And I see my 2 waters. So on this side, like I said, we had a +4 and a -1. So I need to have 3 electrons added in there. Okay. Step 6. Step 6 takes a look and says, let's balance the electrons. Here I've got 2, here I've got 3. Common multiple will be 6. Okay, so to do that, let's go ahead and I'm going to take 3 times the whole zinc thing. Now I'll line up my arrows. Remember, that's a 3 to everything here. And let's take a 2 to the entire second part. Right? Whew, that's a lot of stuff, isn't it? Now let's take a look at step 7, which means that I'm going to add up the equations. Now here's the part where all of this due diligence was going to help out. Let's take a look at the top. I have 3 zincs. Let's put my arrow over here. So that's taken care of. I have 6 electrons. I have 8 hydrogens. I have 2 nitrates. That's everything that's on the reactant side. Now let's take a look at the product side. I have 3 zinc ions. I have 6 electrons. Okay, over here I have 2 nitrogen monoxides and I have 4 waters. That's everything on the product side. Okay? Now, we can get rid of our electrons in step 8. Okay? I see I have 6 and 6, and so we cancel out the electrons. What am I left with? I'm left with 3 zincs, 8 hydrogen ions, 2 nitrates, 3 zincs, 2 nitrogen monoxides, and 4 waters. There is my balanced redox. Okay. All right. Good job. Now let's take a look at example 9. Example 9, I'm going to start out by doing all my oxidation states. Okay, so solids, here's my my oxygen. My hydrogen's a +1, hydrogen's a +1. Okay, so then I see I've got a -4, this is a +4. I see that this is 6 +1, this is a +5. I see that this is a 2, this must have been a +2, and we're taken care of. Oil rig, oxidation, reduction. Okay, so who loses electrons? Okay, I see that I'm going to be becoming more positive. Who ends up being more positive in this case? Well, I see that my, let's see, that my oxidation is my sulfur. Okay, I see that my sulfur right here is becoming from a 0 to a +4. Okay, so my sulfur goes from a 0. Oops, I don't know why that keeps on coming up every once in a while. Goes from a 0 to a +4. Okay, and it becomes that +4 within the sulfur dioxide. Okay, then I take a look and who's getting reduced in this case. The reduction is going to be my nitrate. And the reason is right here. Okay, so my nitrate becomes reduced because this was a +5 and it becomes a +2 in this case. All right, so that's going to be that piece. Now let's go ahead and let's balance everything except for my oxygens. Sulfurs are balanced, nitrogens are balanced. Okay, now let's go ahead and balance my oxygens by adding water. I see that on this side I have two oxygens, so let's go ahead and in step 3, let's go ahead and add 2 waters. Okay, and I see on this side I have 3 oxygens, and on this side I have 2 oxygens. Okay, so getting this all organized, I have NO, and so to keep them balanced, 3 on this side, I have only 1 on this side, so this is 2 waters on this side. Okay, so there are my waters. Now let's go ahead and balance my charges. Okay, or sorry, I missed a step. Let's balance my hydrogens. I've got 4 hydrogens on this side. I've got 4 hydrogens ions on this side. I've got 4 hydrogens on this side, 4 hydrogen ions on this side. Okay, so that's taken care of. Now let's balance those electrons out. I forgot about the hydrogens in there. Okay, so I have 4 hydrogen, 4 +4 on this side. And so that means that I'm going to have to get a couple of, let's see, I've got to get 4 electrons right here. I see that I've got 4 minus 1, so it's a +3. And on this side, it's neutral. So I've got to balance that out with 3 electrons on this side. Okay, so you see what I'm doing? I'm not rewriting every time. Now I can see my common multiple. Okay, 3 here, 4 here. My common multiple is 12. Okay, so let's take a look. Now let's put and distribute a 4 to everything that I just created. All right, so a 4 to my 3 electrons, my 4 hydrogen ions, my nitrate, and my nitrogen monoxide, and my water, my H2O. Let's get a 3 to this side. Okay, so I've got a 3 to my 2 waters and my sulfur. To my sulfur dioxide, my 4 hydrogen ions, and my 4 electrons. Okay, so that's all taken care of. Now let's go through and see what we end up with. All right, so I've got, this is step 7. I've got 12 electrons. I have 16 hydrogen ions. I have 4 nitrates. I have 6 waters. I have 3 sulfurs. Product side, I have 4 nitrogen monoxide. I have 4 waters. I have, let's see, 3 sulfur dioxide. I have 12 hydrogens. And I have 12 electrons. Okay. Now, I see that on both sides, if this is all taken care of, I have 12 electrons. Those are gone. I see I have 16 hydrogens here, and I have 12 hydrogen ions here. So I can use up all 12. That means I have 4 hydrogen ions remaining. Okay, that's why we're doing this problem, to see the pieces. Okay, I see that I have 6 waters on this side. I have 4 on this side. I can use up all 4 of those to get 2 waters remaining here. Okay, so now I should have everything taken care of. Let's take a look what I have left at the end. I have 4 hydrogen ions. I have 4 nitrates. I have 2 waters. I have 3 sulfurs. I have 4 nitrogen monoxides. And I have 3 sulfur dioxides. Everything is balanced. Cool. Last one. Do one more, and that'll be it for this section. Okay? One more in here, and let's take a look at a big, long, nasty one. All right. Potassium permanganate. Okay, so -2, -2, -2, -2, -2, -2, -2, plus ones, plus ones. Let's see, that takes care of that. Now my potassium is a +1, and that should take care of those. All right, so 8 plus 1, this must have been a +7. Let's take the manganese on this side. This is a -8. Sulfurs in column 16, so that's always going to be my negative. Oh, that's going to be that one that's a little bit different. This is 8. This is going to be a +2, so that's a +6. So this ends up being a +6 as well. My sulfur is going to be changing here. Okay, so I have 2 times 4 is 8 times 3. Okay, so it's 24. This becomes a little bit ugly. And my iron ends up being a +3. And this is a +6. And let's see, on this side, -8 plus 2. So there's a +6 there. -8 plus 2 plus 6 there. This one is going to end up being a +2 to balance out. So this 8 plus 2 plus 6. And now we're taken care of. Okay, so taking a look at redox with this one. The part that's going to be reduced in this case is going to be my manganese right here. Just that piece. The manganese is going from a +7 to a +2. Okay, so the manganese ends up being a -1 charge, and that's going to form my manganese with a +2 ion. Okay, this is a +4, or sorry, a +7. Okay, what's being oxidized? Okay, what's being oxidized in this case is going to be my iron is going from a +2 into an iron that's a +3 right here. Okay, so let's go ahead and balance our elements. Those are done. I need to balance my oxygens, so I'm going to add in 4 waters. Okay, now I need to balance my hydrogens. I have 8 of those. Hydrogens are balanced. Now I need to balance my electrons. Okay, here's 8 plus 8. Let's see. And on this side, I see a +2. Okay, so I have a -1. I have a +8, so I'm at a +7. And I have a +2 on this side, so I'm going to have to add 5 electrons here. Down here, I see a +2, and on this side, I see a +3. So I need to add 1 electron here. I have 5 electrons and 1 electron. So that means that, let's see, I need to have, in this case, a 5 and 1. That means that I need to have a 5 around this entire thing. Okay? So, having said all of that, let's take a look and let me rewrite because it's getting a little bit messy. I see that I have on this side 5 electrons. I see that I have 8 hydrogen ions. I see that I have 1 permanganate. I see that I have 5 irons. That's a +2. Okay, product. I see I have a manganese. I see that I have 4 waters. And let's distribute that 5 into here. I have 5 irons. That's a +3. And I'm going to have 5 electrons. Electrons are canceled. I see, let's see, I think that's about it, isn't it? I see I have 8 hydrogens there. And off of all of this, I end up with 8 hydrogen ions plus my manganese my permanganate plus my 5 irons. That's going to give me 4 waters and 5 iron ions. Okay? And off of all of this, let's pop because I don't have my permanganate by itself, let's put my potassium back in. Okay? So to do that, I ended up with potassium permanganate. I can't have the ion by itself, so what I lost was my sulfate in there. And so I ended up with 5 iron sulfates. I ended up with 4 waters. And let's put my sulfate back into here. I ended up with 5 iron 2 sulfate, or iron 3 sulfates. There. And it's all balanced. This is my +2 charge, there's my -2 charge. And that's just if I'm going to put everything in without without any free-floating ions floating around in there. Again, I just ditched those guys for a little bit to get the thing to balance a little bit simpler, but there's my equation. Whew. Nice job sticking through all these things, and that should be getting us through the rest of the problems for redox. Okay? Just a reminder on this at the end, what you'll be doing is the steps in there. The only thing that's going to be doing different is you'll add hydroxides to eliminate the hydrogen ions in there. Okay? I'll take a look at that in the next video. Good job.